Hi there. Today we are gonna learn about fractions. Let's get started. What is a fraction? A fraction represents a part of a whole. Let's say, for example, a circle. This circle represents a whole like a whole cake. If we divide this whole circle into 5 parts, we call each of these parts a fraction of the whole thing. Mathematically, this is how we show it. We know that fraction is parts of something. So here, the top is numerator, the parts we have. The bottom is denominator, the parts that something is divided into. For example, this circle is divided into 5 parts. So the number in the bottom, the denominator, is 5. Let's say we have 2 parts of this circle. So the top number, the numerator, will be 2. We have 2 over 5. Let's check these circles. The first one is a whole circle. So it is 1. The second one was divided into 2 parts, which mean the bottom number is 2. Since we have one of them, the top number is 1. So 1 over 2. This circle was divided into 4 parts. So the bottom number is 4. We have one of them, and the top number is 1. So it is 1 over 4. Lastly, this circle was also divided into 4 parts, and we have 3 of them. So it is 3 over 4. Let's say, for example, we have a rectangle, and it was divided into 3 parts. So the bottom number is 3. We have 2 of them, and the top number is 2. So it is 2 over 3, comparison of fractions. We compare fractions to check whether a fraction is less than, greater than, or equal to another fraction. For example, let's compare 5 over 7 and 2 over 7. Let's show these fractions visually in a circle. So we have to circle each of them with 7 divided parts, since the bottom of the both fractions are 7. One of the circle's 5 parts is shaded, and the other circle's 2 parts are shaded. The first circle shows 5 over 7, and the second circle shows 2 over 7. From these circles, you can see that 5 over 7 is greater than 2 over 7 because more parts of this circle is shaded. Let's compare these fractions: 4 over 8, 2 over 4, and 1 over 2. If you have already noticed, the bottom numbers of these fractions are different. Let's show these visually in circles. In the first fraction, 4 over 8, we divided the circle into 8 parts and shaded 4 parts. In the second fraction, 2 over 4, we parted the circle into 4 parts and shaded 2 parts. Finally, for 1 over 2, we divided the circle into 2 parts and shaded 1 part. When we compare all these 3 circles, we can see clearly that the same amount of the circle shaded. So these 3 circles are equal. These type of fractions called equivalent fractions. Even though these type of fractions has different top and bottom number, they are equal in value. Keep in mind that if you multiply or divide both the numerator and the denominator of a fraction by the same number, the resulting fraction is equivalent to the original. Let's say, for example, 2 over 7. If we multiply the numerator and the denominator by 3, the resulting fraction will be 6 over 21. So 2 over 7 is equal to 6 over 21. This is why 4 over 8, 2 over 4, and 1 over 2 were equivalent in the previous question. If we multiply the numerator and denominator of 1 over 2 by 2, it becomes 2 over 4. If we multiply the numerator and denominator of 2 over 4 by 2, it becomes 4 over 8. So all these fractions are equivalent. We also showed it visually in a circle. Let's try another one. What if we compare 2 over 3 and 3 over 4? You can see that both fractions has different bottom numbers. Let's show both these fractions visually with rectangles. For 2 over 3, we divided the rectangle into 3 parts and shaded 2 of them. For 3 over 4, we divide the rectangle into 4 parts and shade 3 of them. When we compare these 2 rectangles, we can see that 3 over 4 is greater than 2 over 3. There is also another way to compare these type of fractions that has different top and bottom numbers. We know if the bottom numbers, the denominator, are same, the comparison between fractions are easy. So we can compare fractions with different denominators by making the denominators the same. Let's show this in an example 5/6 and 3/4. To make the denominators the same, we need to find the least common multiple LCM of both denominators. We have already learned about how to take the LCM of numbers in our last video. Let's find the LCM of 6 and for using prime factorization. We start dividing both numbers by the smallest prime number, which is 2. So 6 divided by 2 is 3, and 4 divided by 2 is 2. We leave 3 since it cannot divided by 2, and divide 2 by 2, which will be 1. Now we divide 3 by 3, which will be 1. So the LCM is 2 times 2 times 3. This is 2 to the second power times 3. So the least common multiple LCM of denominators is 12. To change 5/6 to a fraction with the denominator of 12, we need to multiply both the numerator and the denominator by 2. So it is gonna be 10/12. To change 3/4 to a fraction with the denominator of 12, we need to multiply both the numerator and denominator by 3. So it is gonna be 9/12. Now we can easily compare 10/12 and 9/12 since they have the same denominators. 10 is greater than 9, so we can see that 5/6 is greater than 3/4. That's it for today. We learned about fractions, how to represent them, and how to compare them. Thanks for watching.